Okay, so we are going to start Unit 7, which is about dilations and scale factor. So we've already discussed three types of transformations. There's rotations, reflections, and translations. This would be in Sec 1. Remember, a rotation means to turn. A reflection is like a mirror image. And then, so like if I had a heart, and then if I turn the heart, and a translation is to slide something. So we can slide it to the left, to the right, and then we can slide it down, so kind of diagonally. That would be a translation, just as review. Then we've learned about dilations, where you make something larger or smaller, but you keep the same shape, but we want to go a little bit more in depth in this class. So on dilations, it is to become wider, larger, or more open, or smaller if we have a different scale factor. So everything when you dilate on the XY axis, you can think of it that way, it is going to expand around a certain point. Okay, so let's look at an example. So the notation is the D stands for dilate. The O, this would stand for origin, which is at 0, 0. And 3 is our scale factor. Okay? And this would be like the point or the object, I guess, if you want to think of it that way. Okay? So if we can also write these directions out in words, but if we want to use the compact notation, we can do it that way. Okay, so a visual example would be if I was dilating about just point O. Notice if I start with A, B, C triangle, the image that I create after I've dilated it has a little apostrophe after it, which we say as prime. So A prime, B prime, and C prime. Okay, so this is like my before or the original. And then this is the after image when we have performed the dilation. Okay, notice if we are dilating triangle ABC about the point O, when you dilate each point individually from point O, you can still connect them on the same line. Okay, so that's going to be an important feature, especially when you go to work backwards to find that point of dilation, okay, because sometimes that's not given. All right, so when would we use dilations in real life? Actually, a lot. So I use it a lot when I do enlarging and reducing images to make these activities for you. Architectural perspective, so when people are drawing things or they want things to look a certain way, you need to consider this viewpoint. You might have even done this in an art class. Scaled house plans and machinery parts, because obviously if we're building a tractor, you need to scale it down to size on a piece of paper, but there's tons of different applications, okay? So the center of dilation is the only point that does not move. So notice like on O, when I dilate ABC, O stays the same. Okay, we don't move that. All the other points should move. The scale factor tells you how much an object is going to expand or contract. So if your scale factor is more than 1, your after image is going to be larger. If your scale factor is less than 1, then your object is going to get smaller, which we call contract. Now, what happens if our scale factor is 1? Yeah, hopefully you thought, well, if our scale factor is equal to 1, then I have that same object and it didn't move at all. Okay? So, think of a scale factor as 1 as being 100%. Okay? So, in my first example, and I've got 3 different types, what I want you to do is it's a dilation with the center of dilation at the origin. Okay? So, in the following picture, the origin is the center of dilation right here. And so we want to perform the dilation with a scale factor of 3. Now, you have some choices. if I put this on a grid, and let's say even if I had an object and I wasn't given an XY axis, you could always add one in. Like up here, I could add in an XY axis, okay? And then I could like visualize what ordered pairs these would be. So keep that strategy in mind. This might be the easiest for students, especially if you're struggling with visualizing the outcome. So if it's scale factor of 3, what that means is it's going to be a rectangle that's 3 times as large as this original brown rectangle, okay? And it's about O. So when I go to draw my line, remember they should all be on the same line from the origin. So what I do is I write the ordered pairs for each of them. And you can do this on the graph or you can do this in your head. That's fine. So A is at 1, 1. D is at 1, 2. B is at 4, 1. And C is at 4, 2. And so remember, the object is going to move because it also needs to be 3 times the distance from the origin. So when I go to find my new answers, we label that as A prime, B prime, C prime, and D prime. And I'm really going to triple all of these ordered pairs. And that actually does the dilation from the origin, okay? So notice I'm only going to be able to triple it when we're working with the origin. So that's the first thing you need to understand. So if I triple 1 and triple 3, then I'm going to triple 4 and triple 1, triple 4, triple 2, and then triple 1 and triple 2. And these will be the ordered pairs of our new rectangles. So A is at 3, 3. I'm going to try to draw this as straight as I can. So that's going to be A prime, I like to label it. And then B prime is at 12 up 3. Oops, I'm going to be in my own way, aren't I? That's okay. And then C is at 12 up 6. No problem. And then D is at 3, 6. I just happened to write where I needed it. So 3 up 6. Okay, and then I'll connect the dots. Now, I'm not the best straight line drawer, as you've seen. But the points, you can't argue with that. All right, and so now this would be done. I might just ask you an ordered pair. I might ask you to make a graph. It really just depends on what the questions are. But notice if we use that idea that from the origin, these should all be on the same line. And I really wish I could draw better straight, but I can't. Let's act like that is. But you get the idea. These really do line up. And so if I didn't know, like if I was just given this shape and that shape, to think backwards, you need to use that relationship and find out where do all of those lines verge. And then that's going to be your point of dilation. Okay? Because I do have a question like that on your practice quiz. All right, example number 2. So even though I only asked one question, this could answer a lot of different questions. Okay? All right, example number 2. Now we're going to have the dilation with the center of a point, but we're going to talk about a different strategy. So determine the slope of GA, so here's G to A, from one point to the other point, so G to A. So remember, slope is y minus y over x minus x, and so this will also work when my point is not the center, okay? So we're going to do purple. So from G to A, I get y minus y, and then x minus x. So 2/3, okay? And so what I also like to do, I can use the slope, but my other strategy was I would just count to go from here, G to A, I have to go up 2 and to the right 3. Okay, keep that in mind. And then using the graph on number 2, how can the slope help us to find A prime? So what we want is we want a scale factor of 2. So that means I need to have 2 of these to get there. So I could go, if we want to find A prime, so I need to move that. So I'm going to go up 2 and over 3, but I need to do that twice. So up 2, and we're going to have to estimate, and over 3. Okay? And that would be A prime. Using graph number 3, how can the slope help us find A prime? So what I know is if my slope has to be on the same line, then I know I'm going to keep extending this. And we want to use 1/2. So I really just want to go half of that, but on that same line. So I could find the distance, and then I could find the midpoint, since it's half, or same idea, I can split that distance up in half. So instead of going up 2, I'm just going to go, and half means to get smaller in the other direction. So I'm going to go down 1, and then we went to the right 1, 2, 3, so I'm going to go back 1.5, so 1.5. Now notice my new point is on that line, and that has to be true, okay? So when you have a smaller scale, less than 1, you're going to take the opposite of the slope. But the slope of the line is what's really helping us double check that our answer is on that original line. Just like if I would have extended this one to be 2, and I had to estimate that. So this should have been up a little bit higher for that one to be on the line, okay? But that's a bad, okay? All right, so example number 3, we're going to try a scale factor less than 1. Remember, that's called a contraction. And we just picked half of it, okay? So these would be the same ordered pairs. And since I know it's a half, remember, and we're using, let's go ahead and pick, over here. So A is 1, 1. This is a better graph because it has the little decimals for us, but B is at 4, 1, C is at 4, 2, and D is at 1, 2. Okay. So our new is we're going to take half of these. So I get half, half, half of 4, half of 1. I'll go ahead and put the decimal. Half of 4, half of 1. I'm sorry, half of 2. And then D is half of 1 and half of 2. Sorry, sometimes I can't talk it right. So A prime is going to be 1/2 and 1/2. B prime is at 2 and then up. C prime is at 2, up 1. And then D prime, 0.5, up 1. And so you'll notice each of the side lengths are actually half as long as the original, okay? All right, so let's say, I'm going to add in an example. What if I wanted this same thing, but I wanted to rotate about the point, let's make it 5, 1. So now I want this to be my center of dilation. Okay. So I'm going to go ahead and erase this so we can have a fresh slate. Now, when I change that center, it does get a little trickier. I need to, and we'll keep the same thing, we'll just say 1/2. So what I notice is I kind of count the distances. So I say, okay, from my center to B, I'm really going to make that, and I call these kind of like fake ordered pairs. So I want to go from to get to, I'll just put B. So I'm going to go to the left 1. So left 1. And to get to C, I'm going to kind of do the same thing. I'm going to go left 1 and up 1. So left 1, up 1. To get to A, I went to the left 1, 2, 3, 4. And then we didn't go at all. And then to get to D, we went left 4, up 1. Now, if you want, you can write these as fake ordered pairs, left and then up 1, okay? So I could make this like -1, 0, but it's from this new order. So I act like that's the origin. So act like it's the origin, because it's the origin for your dilation. And then you could either use words, or I could write these as ordered pairs, okay? But it's from that red dot, not from the original O. So I could make this one really -1, up 1. I could make -4, 0, and then I could make this -4, +1. So when we go to do our dilation, well, I'm still going to take half because I'm just going to keep it the same. But now I need to take half of these directions or of these values. So I really just want to go left half. And so I say, oh, well, I can go left a half. It's right here. The same thing with C. Well, I want to go left a half and up a half from this red dot. So left a half, up a half. And then D, I'm sorry, I went to A. So A, take half of that. So I'm going to go left 2, and that's it. So here's 4, and then here's that 3. And then D, we're going to go left 2, and then up a half. So left 1, 2, up a half. Okay, so if they change that center of dilation or the point of dilation, you can just use verbal directions or make your own new ordered pairs from that center.